Hi everyone. In this video, we are going to learn about linked list. Linked list is linear dynamic data structure. Why we are telling it as a linear is will not have different levels. It will be in a single line like. Why we say dynamic is the size of the linked list need not be fixed actually. We will be able to decide the size dynamically. So whenever we want to insert the element, then we can create a node and insert the data. And whenever the element is deleted from the linked list, the length of the linked list will be reduced, obviously. Similarly, the memory being occupied by the deleted node also can be freed. So that is the reason why we call this as dynamic data structure. The elements in the linked list are stored in random memory locations. Suppose, let me say, like we are having 5 elements in the linked list. These 5 elements need not be in consecutive memory locations, means one after the other. The elements in the linked list need not be stored in the sequence. They can be in different locations which are randomly distributed in the memory. What is the structure of the node of the linked list? We'll be having two parts, that is data and pointer to the next node. So pointer is nothing but what we say as link to the next node. It is a chain of nodes linked in a sequential order. Chain of nodes means one node will be connected to other node like this. Whatever the nodes we will be having in the linked list, they will be connected to each other. So the first node in the linked list, we will be referring it as a head node, and the last node will be referred as tail node. And this tail node will be having a pointer to the next node as null pointer, because after that particular last node will not have any node actually. So the pointer to next node will be a null pointer. There are different types of linked list. Basic types are singly linked list, doubly linked list. And in singly linked list and doubly linked list, we'll have circular singly linked list and circular doubly linked list also. So what are the advantages of linked list? As we have discussed before, it is a dynamic data structure. It means it need not have a fixed size. The size of the linked list will be varying as on the nodes will be inserted or deleted. Insertion and deletion is very simple actually when compared to the arrays. The array elements are stored in the consecutive locations, but in the case of linked list, they are stored in the random location. And this is also like one of the reason why it is easy to insert and delete the elements from the linked list. And the memory efficient. The size of the linked list can grow or shrink according to the requirements. So memory consumption in the linked list is efficient. Because the memory is being created only when we want to insert a node. And once the element is deleted, we will be making the memory free for use of any other purpose actually. So that is the reason why we say that memory is efficient. Implementation also is another advantage of linked list. That is, we can implement both stacks and queues using linked list. There are many other data structures which can be implemented using linked list actually. What are the disadvantages? Memory usage. Why we are telling that memory usage is a disadvantage is we'll be having two parts, that is data and a pointer actually, right? So the memory being occupied by the data and also the pointer. Then traversal. Traversal is not easy in the linked list. If we have to access an element in the linked list, we cannot access it randomly because we will not have any index to be used for the traversal purpose. Suppose if we want to access the last node, right from the beginning, you have to access each and every node and go to the last node. And from the last node, if you want to come back, actually, you cannot come back. Again, you have to start from first node, that is head node itself. So traversal is a bit difficult, means it should happen in a loop actually. So that is the reason why we say traversal is not easy in linked list. The next one is reverse traversing. Reverse traversing means, suppose if you have traversed till the end of the linked list, and from there, no, like if you want to traverse in a reverse way, it is not that easy in the case of linked list. Now, in normal or general linked list, it is not that easy actually. But to overcome this particular problems, doubly linked list has been introduced. So in singly linked list, it is difficult, but in doubly linked list, no, you can do reverse traversing in an easy way only when compared to single linked list. What are the applications of linked list? With the help of a linked list, the polynomials can be represented as well as we can perform the operations on the polynomial. No, like we'll have, right, like ax square plus bx plus 2, or no, more powers also, cubical expressions, like this. These can be expressed in the terms of linked list actually. And we can perform the operations also on these polynomial expressions. And linked list can also be used for the sparse matrix, where we are going to have more number of zeros when compared to the ones. And the databases like student details, employee details, product details, etc. The advantage of linked list is different types of data types can also be inserted in the same linked list. Means in one particular node, I can have any amount of data. Means like, let me say for student details, if you are going, student roll number, name of the student, contact number, and then we can have the pointer to the next node. Like this, we can have in the case of linked list actually. So that is the reason why we say that different data type values can be stored in a single linked list. Using linked list, we can implement stack, queue, tree, and other various data structures. This already we have seen in the case of advantages, and we are including in the applications also because linked list is used to like to implement stack, queue, and other data structures actually. The graph is a collection of edges and vertices, and the graph can be represented by an adjacency matrix. So when you are talking about the adjacency matrix, it is using arrays, and adjacency list, it is nothing but using linked list. So graphs also can be implemented using linked list. A linked list can be used to implement dynamic memory location. Dynamic memory allocation is a memory allocation done at runtime. Means whenever the memory is required, whenever we want to create a node, then it is possible to do so. So that's why dynamic memory allocation is possible using linked list. Okay. Thank you.